Hi, sixth grade. Welcome to another fun day of some distance learning. All right, today, last lesson before our mid-chapter test. See how much you're learning. Today we are getting mad. Not really. Today we are figuring out the mean absolute deviation, which in math they will abbreviate it as mad. All right, but yeah, so today we're going to get mad. No, we're not getting mad. We're just going to figure out what this means, mean absolute deviation. Okay, so first of all, what does this mean? What does mean mean? That's right, mean is the average, right? Good, okay. So today we're figuring out the average deviation of a data set. Okay, so what does deviation mean? Deviation, if something deviates, so Mr. Frank's pilot, here's my little plane. Yeah, it doesn't look like a plane, but bear with me. So if a plane, say I am flying to this runway here, and I'm like, but I have to deviate, so I have to fly somewhere else. So I'm flying and I'm deviating. So mean absolute deviation is how much does the average, how far away is it from another average? Okay, so that was a little mouthful there. Okay, so let's do this. Let's figure out this mean absolute deviation here. So this is our problem. So we have the number of magazine subscriptions sold by 2 teams for students of a drama club is shown below. The mean is the number of subscriptions for each team is 4. Okay, so we're going to, step 1, need to know what the mean is. So we're going to make a dot plot for this data set here. So step 1, as it says, make a dot plot, draw a vertical line through the mean. Okay, so they told us what the mean is. We don't need to calculate it. So the mean is, and let's actually do this here. The mean is 4. So I'm going to put thing, and I'm going to draw a line through the 4. Whoa, there's 2 of me. Go away, me. All right, so we'll put a mean through the 4. Okay, we also know 4 is going to be on this side. So we'll put our line and put a line through it. Okay, next thing I'm going to do is I am just going to make a dot plot for the rest of the numbers. So I'm going to say 1, 1, 5 is 1, 1. So that's team A. Go back here to team B. I got a 0. I got a 1. I got a 4, which I already have dotted. I got a 7. And I got an 8. Okay, so now I have my dot plot all done. Okay, next thing I'm going to do is I'm going to count the distance between each dot plot and the mean. So now I'm going to count the distance. So, okay, I know this is the mean. So this is how far away. Well, I count it. This is 1 space away. Okay, this is how far away. This is 1 space away. Okay, how far away is this? This one is 1, 2, 3 spots. How far away is this one? 1, 2, 3, 4 spots. This one is 1, 2, 3 spots, and this one is 4 spots. So I'm keeping track of that because I'm going to need to use that data here. Okay, so now I'm going to find the mean of the distances. So we already counted the distances. So in the first set, we had 1 plus 1, so we'll just add it up. So here, let's see. So we're going to say, okay, 1 here, 0, 1 here, 1 here. So now I'm saying 1 plus 1 plus, so that's 1 plus 1 plus 1 plus 1 and plus 0. Well, that equals 4, right? And now I just find the mean of that. So I have 1, 2, 3, 4, 5 data sets. So as it says right here, we divided that by 5. Okay. And, oh no, I don't know what that equals. Well, what we can do is we could do the math, right? We could say, well, 5 goes into 4. Turn it into a decimal here. 5 goes into 4, it doesn't go in, so we'll say 0, make it 40. That, of course, goes in 8 times. So the mean of team A, the mean is 0.8. Okay, so now we need to figure out the mean of the other data set. So this one is 1, 2, 3 spaces away. So I'm going to write that down. 3 spaces away. This one's 1, 2, 3 spaces away. This one is 4 spaces away. And this one is 4 spaces away. Okay, so 4 plus 4 is 8, 9, 10, 11, 12, 13, 14. So we get 14. Okay, and I guess to be good, I probably should have added the plus 0 because this little guy here will play into it. Okay, so I have 14. All right, so now I'm going to say 14 divided by how many data sets do we have? 1, 2, 3, 4, 5. Okay, and again, I'm going to say 5 divided by 14. 5 goes into 14 twice. That's 10. I minus that. I get a 4. I'm not allowed any remainders, right? So what do? Ah, you're right. My friendly decimal 0. And okay, so the mean absolute deviation on this one is 2.8. And sorry about all my scribbles. Okay, so I know that set B is 2.8. Set A is 0.8, or let's be more mathematical, 2 and 8 tenths, and this one is just 8 tenths. Okay, so we figured that out. Next, let's do another one. Come on, work. Okay. There's another one. Okay, so label each dot with the distance from the mean. All right, so what is the mean of this data set? What is the middle number? Well, it is, let's see if it tells us. The mean of the ages is 10. Okay, so it tells us off the bat what the mean is. If not, we could calculate it. We could add them all up and divide by that many numbers. But luckily for this lesson, it's going to tell us what it is. Okay, so here we go again. Let's get whoa, look at all that scribble going on there. Let's get a new one going here. Whoops, bear with me. Let's get a new one. Here we go. And before we do it, I'm going to move this up so we can have a little more room. Remember that our mean is 10. So I'm going to put a line through. Whoop, can't do it till I press the ink button. Okay, I'm going to put a line through our mean here so I remember it's 10. Okay, now I'm thinking how far away are these numbers away from 10? Well, 9 is 1 away from 10. These are all 2 away from 10. These are all 0 away from the mean. This one, there's no dots. I don't have to worry about it. This one is 1, 2, so 2, 2, 2, and this is 3. Okay, now to find the mean absolute deviation, I just have to add all these numbers up. So I'm going to say 2, 4, 6, 8, 10, 12, 14, 15, 16, 17, 18. So 18 is when I add it up. And then I'm going to divide it by, so I know there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Okay, this one's a little harder, right? So 12 goes into 18 once. Okay. 18 minus 12. What, I got 6 left over. And because 12 go into that? Nope. So decimal 0. And 12 goes into 60. What's the closest I can get? What is it? 4 times, which is 48? No, duh, Mr. Frank. We'll go in 5 times, which is 60. Duh, Mr. Frank. Old man moment there. All right, so my mean absolute deviation is 1.5. Or to say it mathematically, 1 and what? 1 and 5 tenths, since 5 is in our tenths column. All right, so we got mad today. That is how to do the mean absolute deviation. Again, if you have any questions, any comments, anything, I'll be on my email. I'll be on Dojo. I will be on Google Classroom, all that good stuff. So please don't be afraid to ask. Thanks, guys. We'll see you on the funny pages.